Hi students, today we will discuss about crystal nature of carbon. So carbon have so many phases. This means crystal means so many phases. So it will be combined with the four other atoms in a four sides. So that we will call like crystal nature. So it will be uses so many types. Like a knife have two sides sharpness is there, means how we will use same. Carbon have crystal nature. We can use any way, any method, any in compounds. It will be combined with any other element, like this have this type of special nature for carbon atom. So here catenation is the first point. Catenation. So catenation, what is catenation? Catenation means catenation catenation means the property of carbon element due to which its atoms joined are linked with one another to form a large carbon chains is called catenation. Ability to connect are due to which its atoms join or link with one another to form long carbon chains is called catenation. So this is the catenation property. So self linkage, another way of definition, self linkage of carbon atoms is known as catenation. So the compounds may have long chains. These compounds may have long chains or branched chains. Even carbon atoms arranged in rings so long chain and branched chains and ring structure also is there. What is long chain? Example I will show you. Carbon like this. Carbons is there, means that is long chain. Branched means I will show you for that also example. Carbon like is there. Here one carbon, for here one carbon is there, means this is branches. For this also one more carbon, like branches. Ring means that how many carbon atoms, that carbon atoms forms a ring structure. So this is the catenation property. Next, tetravalency. Next crystal nature is tetravalency. Crystal means correct word is so many phases. Not phase, phases. Okay, tetravalency. So atomic number, carbon atomic number is 6. Valency is 4. Electronic configuration is 2, 4. So valence shell have 4 electrons, that only valency. That only valency. So this is about valency and valency electrons. It can bond with 4 other atoms of carbon. Carbon atom can bond with 4 other 4 other atoms of carbon. 4 atoms of carbon are atoms of monovalent elements. Atoms of monovalent elements. If carbon combined with carbon atom are monovalent other elements. What is monovalent other elements? Carbon forms a compound element. With that, carbon forms compounds. Carbon forms compounds with here elements. Here full stop. Next, carbon forms compounds with which one? Oxygen, nitrogen, and then hydrogen, sulfur, and then chlorine, and many other elements. Carbon will form bonds with the carbon atoms only, or other atoms of monovalent elements are oxygen. Monovalent means like valency 1. Like what is that? Hydrogen atoms. So divalent atoms also is there: oxygen, nitrogen, sulfur, chlorine. Sulfur is polyvalent. So like this is catenation and tetravalency. Next, strong bond due to small atomic size. Strong bond. Carbon have strong bond, no? Because of due to small atomic size. So carbon atom size is small, so that only the bond that carbon forms the most carbon forms a most forms with most other elements are very strong due to very strong bond, that is due to its small size. Carbon forms bond with the most other elements very strong due to its small size, making this small size making those bonds very stable. So because of this, nucleus to hold on to the shared pairs of electrons electrons strongly. Shared pair of electrons strongly. So that we will see once. For example, carbon atom have 4 valency electrons like this. So 4 hydrogens have, each hydrogen have one electron for its valency shell. So shared pair of electrons like this pair, it will be sharing means, so size is a small size carbon atom, so that only that bond will be very strong. These 4 bonds will be very strong. The shared pair of electrons strongly bonded. So that is the meaning of this one. Next, hydrocarbons. Next, hydrocarbon means what we will discuss. Hydrocarbons. Hydrocarbons means the compound made up of hydrogen and carbon only. Hydrogen and carbon only we will call hydrocarbons. Carbon only. All other, so okay, carbon only called hydrocarbons. Next, all other, these are the simplest organic compounds. These are the simplest organic compounds. So which is organic compound? Hydrogen and oxygen is there, means that is the simplest organic compound. That is only we will call hydrocarbon. Next, hydrocarbon, its derivatives also is there, organic compounds. That means what? All other compounds are considered to be, all other atoms or compounds are considered to be derived forms. Their derivatives, like derived from them means from the hydrocarbon their compounds will come. From where? From their hydrocarbon. Simplest organic compounds means hydrocarbon. From the hydrocarbon their derivatives also will come. Where? From hydrocarbons only. So that only hydrocarbons and their derivatives, organic compounds and their derivatives we will call. How it will be formed? No, their derivatives. Replacement of one or more hydrogen atoms by other atoms or group of atoms How it is, I will show you one example. Group of atoms. So that is, for example CH4 is there. This is simple hydrocarbon. Carbon have 4 hydrogens. From this we will add one chlorine atom, means CH3Cl will come. CH3Cl plus HCl. Yes sir, CH3Cl means instead of 4th carbon, so I will show you here. See, like CH4 is there. Instead of 1 hydrogen we are adding Cl to know. In this 1 Cl from here, 1 hydrogen here, it will be HCl removing. This chlorine attached to here means structure how it will come now, CH CH CH, this side Cl. So this is the derivative, hydrocarbon derivative, that only replacement of one or more hydrogen atoms by a other atom. So from because of chlorine atom, hydrogen replaces, yes sir, one hydrogen replaces, no, one chlorine is there, CH3Cl will form. So like that. So this is their derivatives. Next, hydrocarbons, how many types? Two types. Hydrocarbons, two types. One is saturated hydrocarbons, second one is unsaturated hydrocarbons. Okay, saturated hydrocarbon means alkane. Unsaturated hydrocarbons is two types, that is alkene and alkyne. So alkene and alkyne is unsaturated hydrocarbon. Here saturation means what? Unsaturated means what? We will discuss. Saturated means hydrocarbon in which the carbon atoms are connected by only single bond. Saturated means hydrocarbon, the hydrocarbons in which the carbon atoms are connected by only single bonds is known as saturated hydrocarbons, is called saturated hydrocarbons or alkenes. So saturated hydrocarbons or alkanes have general formula is CnH2n plus 2. This is general formula of alkane or saturated hydrocarbon. Or alkane general formula. This is we can apply instead of n we can apply 2 or 1. 1 means what will come? See, if n1 means C1H 1 into 2 plus 2 4 C1H4, that means CH4 means this is the name methane, ANE. Alka means meth, like ANE is there, no, that ANE only, this ANE. Next, instead of n you can take 2, C2 now, 2 into 2 4 plus 2 6, H6, C2H6 means C2H6 means that is what? ANE, ethane. C2 eth, C1 meth. This is nomenclature we will discuss. Just now already I think you know. So next, instead of this one n you can take 3, C3 3 into 2 6 plus 2 8, C3H8 means methane, ethane, propane, ANE will come. Instead of N, you can take 4. C4, 4 2 0. 8 plus 2, 10. H, 10. Butane. Butane will come. So C1 means meth, 2 means eth, 3 means prop, 4 means but. All alkanes, no, all single bonds is there in this structure, so that only ANE will come. So that only, no, saturated hydrocarbons means hydrocarbons in which the carbon atoms are connected by single bonds. So structure also we will discuss, then you can understand. Next C5H12. So 5 to 0, 10 plus 2, 12. So this is pentane. So up to 5 enough. Now I will say about this saturated hydrocarbons. One point I will share. What is that? Not very reactive. This is not, this and all very, not very reactive. All single bonds, no, it is stable. Next, saturated hydrocarbons generally give you a clean flame. It will give clean flame, fire, clean flame, because percentage of carbon, comparatively percentage of carbon is low, comparatively low, which gets completely combustion, which gets completely combustion, completely, otherwise completely oxidized, completely oxidation means clean flame will come, not soot and all won't come. So this is about this one. Now structure of saturated carbon, that means structure of this and all I will write. After that unsaturated we will discuss. So CH4 structure of saturated hydrocarbons, structure of saturated hydrocarbons. So structure 1C, CH4, from here we will come. CH4 structure. So carbon have valency electrons 4. That 4 electrons I want to represent like this. Next, hydrogen also is there. CH4 means 4 hydrogens. That electron I want to represent like red color. So 4 hydrogens, 4 electrons will share covalently. Sharing of electrons will form covalent bond. Now hydrogen is helium configuration. Now hydrogen will get helium configuration. This hydrogen also will get helium configuration, and these hydrogen also will get helium noble gas configuration, right? Noble gas configuration also stable electronic configuration. Now entire carbon will get 8 electrons, right? So in this circle 8 electrons is there. So 8 is there means that is octet configuration. Octet, it is also stable. Structure is this one for CH4. C2H6, second one, C2H6. So C here 1C, this one also having 4 electrons, this one also having 4 electrons, right? All are single bonds. So this one also having hydrogen atoms, this one also having hydrogen atoms. How many hydrogen atoms? 6 only, no? C2H6. So the here one bond, here one bond, here one bond, here one, here one, here one. Carbon also one bond is there. So this is the structure of C2 ethane, structure of C2H6. So now each carbon have sharing with this one also 8 electrons, and now this carbon also having 8 electrons. As it is hydrogens will get 2 electrons like helium. This is also stable electronic configuration. So that is next C3 like H8, 1H, 2H, 3H, 4H, 5H, 6H, 7H, 8H. So carbon have which valency? Tetravalency. Anywhere carbon will get 4 bonds means it is stable. It is a not stable. It is a 4 bonds means it is satisfied. What is that? Tetravalency, satisfied, right? So now each one have bonds also we will represent like electrons we will represent like into marks also ma. So for carbon we are representing into mark. For hydrogen we want to represent dot, Lewis dot symbols, Lewis structures also this is. So how many valency electrons? That valency electron we want to represent means that is Lewis dot structure. With the help of dots we are representing valency electron means that is Lewis dot structures. Lewis dot structures. Now this carbon having 8 electrons. Now this carbon also having 8 electrons. This hydrogen 2. This hydrogen also 2. Middle carbon having 1, 2, 3, 4, 5, 6, 7, 8. So we want to write like this. So this is this one number. Propane structure. Propane structure. Next this one butane structure also. 1 carbon, 2 carbon, 3 carbon, 4 carbon atoms. This one have 1 valence electron, 1 valency, total 4 valence electrons. For this also 4 valence electrons. This is also each carbon same only, no, same atomic number, same valence electrons, like this. So how many hydrogens is there? 10 hydrogens. 1 hydrogen, 1 hydrogen, 1 hydrogen, one more 4, 5, 6th, 7th hydrogen, 8 and 9, 10 hydrogens. 10 only, no? So this one have 1 electron, hydrogen atomic number 1, valency electron also 1. So that 1 electron we want to represent like dot. So this is the dots. Now bond will be formed between these, like this bond, like this bond, like this. Mutual sharing of electrons between them is known as covalent bond. So now all are covalent bonds. So now these hydrogen have 2, these hydrogen also 2, every hydrogen have 2 electrons having, that is like helium configuration, helium electronic configuration. Next these carbon have how many electrons is like this we should represent. Now these carbon also having like this, and this carbon also having like this, last carbon also having like this. Yes, so each carbon 8 electrons. Once check it, 1, 2, 3, 4, 5, 6, 7, 8 for this carbon. Like all carbons 8 electrons is there. This is structural representation of saturated hydrocarbons. So unsaturated hydrocarbons also will discuss next class. Thank you.